Okay, good morning children. Now next topic is electric potential due to a single charge, and you know we have defined it. It is the work done in bringing a unit positive test charge from infinity to a particular point. So now we have to find, this is the main source charge, this is the test charge. If you bring test charge from infinity to this point B, then the potential at this point, that work done will be the work done per unit charge will be potential at this point. So here is the source charge. If this is positive, electric field is going radially outwards. Okay, and so from infinity we are bringing this q naught charge from infinity to B. Suppose in that it comes here at any point A. Now it will experience a electrostatic force in the repulsive way. So it is experiencing force in this direction. Now you are taking it towards this direction. That means you are applying at least that much amount of force which is opposite to the electrostatic force. You are applying force in the opposite direction, opposite to electrostatic force. Suppose you displace it by small amount dr. Okay, so yeah, work done, small work done is equal to F dot dr here, and this is equal to Q naught E dot dr. Okay, Q, because F is Q naught E dot dr. Now minus Q naught E dr. Why minus Q E naught dr? Because E and dr are in the opposite direction. Electric field is radially outward and dr in this direction. So you are getting a negative sign. Cos 180 is negative, so it is coming here. Now, work done from infinity to B will be integral of this expression which you got, integral. Okay, so but Q naught is constant, can be taken outside. E is not a constant. Okay, Q naught is taken outside. Electric field due to source charge is kq by r square. Here k and q are constant, you can take out and you will get integral 1 by r square dr, which is minus 1 by r. Okay, integral 1 by r square dr is 1 minus 1 by r. Now limit is from infinity to r. Now we will put upper limit and then we will put lower limit. So when you will put upper limit, this minus and minus becomes plus. You can take minus outside. So this is 1 by r from r and r. So when you will put this r, 1 by r minus 1 by infinity is 0. So we are getting this. Okay, so we are getting kq q naught by r. Now when you will take this w by q naught here, then you will get kq by r. Okay, so work done at point r, potential at any point r is equal to w by q naught is kq by r. Now if your charge q is positive, then the potential is positive, and if charge q is negative, then the potential is negative. For single charge, V is spherically symmetric. What do you mean by spherically symmetric? That means if you take, see, this is the charge. Now q, source charge. Now if I have to take any point at distance r, my potential will be kq by r. Now consider all the points which are at same distance from this q charge. When you consider all those points, the kind of figure which you'll get will be a sphere. So that is why it is called spherically symmetric. Okay, spherically symmetric. Now electric potential due to group of point charges. Now there is a group. Okay, so many charges are there, and at this point you have to find the potential. So potential is a scalar quantity. Just now I told you, maybe in the previous video. So it will be algebraic sum. Scalar means algebraic sum. Algebraic sum of the potential due to all individual charges will give us potential, total potential. So what is the potential due to the first charge? Due to this, potential here is kq1 by r1. Due to this, kq2 by r2, kq3 by r3. Same way kq1 by rn. So these are the individual potentials. Now using superposition principle, now resultant potential is algebraic sum because it's scalar of the potential due to individual charges. So you just total potential will be sum of algebraic sum of all the potentials. So you add. When you're adding, k is constant everywhere. Take k common. So what is left? q1 by r1 plus q2 by r2 plus q3 by q1 by rn. So we can write k outside and sigma qi by ri, where I goes from 1 to n. Okay, I goes from 1 to n. This you have also used the summation symbol in 10th class, so you are aware of it. Then V is equal to K sigma. Now how to write? This is the resultant. So this is R vector, position vector. So if position vector of point P is R and position vector of any ith element is Ri. Okay, Ri. Then this displacement vector will be R minus Ri. So here R minus Ri. These are vectors, and when you take mod of this, it will become the distance between the 2 points. Okay, fine. Next topic is potential due to electric dipole. This general case is not there in your top syllabus. There is only axial case and equatorial case that I'll do in detail.